And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we'll be talking about major ionospheric anomalies continuing the progression of the solar cycle and what's going on with the closest star. And I realized in the mid-90s that stellar evolution was something completely not understood, and realized that one day I would have to do an in-depth study of the closest star. Here we are. This is the Sun in 335 angstroms, one of the ionized spectral states of hot, gaseous, ionized iron from the Solar Dynamics Observatory. And let's move on to the 193 angstroms view. There is a sunspot up here, 2833. It looks like it may be trying to gain some additional umbrae here, and if it does, we could expect to see a little bit increased activity from it. We saw a bit of a dud when it came to the coronal hole wind stream from this coronal hole down here associated with the South Solar Polar Field region. I think it might be completely over here, folks, although there is a little bit of geomagnetic unrest still forecasted by NOAA. Here's a diagram of the solar system if you're wondering where stuff's located. And we've advanced that 1 week as we approach another full moon. We approach the summer solstice, or I'll just say the June solstice, as we've got viewers in the southern hemisphere as well. And here's a star chart from in-the-sky.org. We've drawn in the ecliptic, which is the yellow line, the sun's path across the sky. And I've faced mine to the south, as I'm currently facing the south. If I were outside right now, it's pretty clear. I think I'd be able to see Saturn and Jupiter near the ecliptic, near the apex of their path across the sky. And the 10.7 centimeter radio flux, the radio output of the upper chromosphere and lower corona from El Sol, the closest star, aka the Sun, at 76 solar flux units. Here's the 1 year chart of the radio flux. It's the black line. The red line below it is the sunspot number. The two most proportional determinants of solar activity, sunspot number and the radio flux. Next, looking at the Space Weather Enthusiast dashboard to see the forecasts for geomagnetic unrest are just ending here. So as we make the video, we're in this time scale here. NOAA no longer forecasting geomagnetic unrest conditions from coronal hole winds, and it looks like they are indeed subsiding. We'll show you the real-time solar wind in a moment. First, let's take a look at global seismicity. By the way, volcanodiscovery.com's got a great set of tools here showing you bar graphs going back to 2018. So you can see the lulls in 7 magnitude earthquakes there. Earthquake droughts typically end in earthquakes, folks, and a statistical analysis is one of the ways that we can forecast earthquakes here, just by saying, hey, not a lot of earthquakes have happened in this period of time. And we're actually seeing a drought of 6.5 and higher magnitude quakes here, as you can clearly see from the bar graph. So if you're in an earthquake-prone zone, please have a plan. Expect things to begin shaking. Don't be surprised to see some things shaking. Anyway, that's not a real official forecast there. Let's sort by magnitude here on Volcano Discovery's latest earthquakes of the past 24 hours, filter by magnitude tool. So we see at least 3 5 magnitude quakes here in the past 24. The largest was a 5.5 north of New Zealand and a 5.5 in China. Let's check the list on USGS. Really, it's a lull in earthquakes, folks, despite some in California and even one in Texas. They're all fairly small magnitude. Fiji region saw a deep quake at over 550 kilometers estimated depth. That was only a 4.4 magnitude. Papua New Guinea saw 5.0. Another 4.4 at Fiji at over 550 kilometers estimated depth. Western South America saw at least one deep quake at 202 kilometers. That one at Argentina, a 4.5 magnitude. Continuing on to check volcanoes, but first, June 15th was the 30-year anniversary of the Mount Pinatubo eruption. If you're not familiar with it, the Mount Pinatubo eruption was sufficient to reduce the global temperature of the planet by a full degree Fahrenheit over the 2 years surrounding the eruption. It also interacted with a typhoon, which is part of the reason why it's on AccuWeather.com's weather news page. So back in 1991, Mount Pinatubo catastrophically erupted. And it was a stratospheric scale injection to the point where that volcanic ash and other gases stayed in the stratosphere for a period of years. And there you can see the infrared imagery of the Mount Pinatubo ash cloud. And interestingly, Mount Pinatubo probably weakened Typhoon Yunya as dry mass of air, and volcanic ash does indeed represent dry mass of air. Indeed, it's tiny rocks floating in the atmosphere. That does not help to strengthen hurricanes. What hurricanes like to see themselves get strengthened is, what helps strengthen hurricanes is moist, hot air and convective processes coming out of warm ocean waters especially. And there you can see the volcanic ash cloud here coming out the top of the cloud tops there. 20,000 people were evacuated from the region during the eruption of Pinatubo. Dispersal of this gas cloud around the world caused global temperatures to drop from 1991 through 1993 by about 1 degree Fahrenheit or half a degree Celsius, the U.S. Geological Survey explained. And let's see what volcanoes are currently erupting. Mount Etna remains on the list, produced a 15,000-foot plume of ash during another likely paroxysm event. Strong Strombolian activity indeed. Mount Ibu exploding as well. Flight level 070, it's a 7,000-foot plume of volcanic ash. Luitolo in the Lesser Sunda Islands exploding. 8,000-foot ash plume there. Semeru on East Java, Indonesia. 13,000-foot ash plume there. Fuego in Guatemala exploding. 15,000-foot ash plume there. Sangay in Ecuador exploding, producing a 20,000-foot plume of volcanic ash. Sabancaya exploding in Peru. 23,000-foot plume of ash there. 13,000-foot plume of ash over Nevados de Chilean as it explodes. A reminder to not pole vault the caldera. This public service message brought to you at massive personal risk and expense by smAshomash.com, who tells you important things like buy low and sell high and do not pole vault the caldera. Why? Because people are stupid. Let's take a look at the GOES 16 imagery. The X-ray detectors on the GOES 16 showing no significant solar flares here over the past 24. And this B-class flare, the only significant flare of the past 24, happened while we recorded yesterday's video. Is it luck? Is it divine providence? You be the judge. Leave us a comment and let us know what you think. No spikes in the proton flux. We haven't seen any coronal mass ejections headed Earth's way. And the channel would have been forecasting that beforehand had it been happening. We do see the Earth moving into a North Pole-oriented current sheet rather suddenly, a little bit more quickly than expected, as the magnetic environment suddenly changed once again. Anyway, here's the 3-day chart of the GOES magnetometer. Seeing a pretty tight range here over the past 24 hours. Fairly low highs and fairly high lows on that. And for you new viewers, the M's and M's represent noon and midnight local time for the GOES 16. Taking a look at the heliospheric current sheet, Earth is now in a North Pole-oriented one. As we look at the last image here, it looks like it's just about to snap across. Keep in mind the data is 1 hour and 22 minutes old. The Earth is already in a North Pole current sheet. And I'll let that play. North Pole current sheet shown here in green. Red current sheet is the South Pole. Green current sheet is the North Pole. It's the top view ecliptic plane field plot, one of the most important factors in space weather forecasting and so on. And we see a progression of the solar cycles happening here. So The next slide, this is the line of sight data for the same data set there. By the way, this is gathered from 51 ground-based magnetometers and magnetometers out here on stereo A and out here on stereo B. And here's the line of sight coronal hole plot. And you can see, number one, we've got North Pole oriented coronal holes here stretching way down toward the equator. That is a serious North Pole. That is a serious North Pole coronal hole there. And you can see the B field being pulled down in this direction, which is something we expect to see during the progression of a solar cycle. And you can see a little bit of that finally happening here as this North Pole-oriented coronal hole system stretches all the way down, and it looks like across the solar equator. Here's the latest image, and indeed it is beyond the equator. So we've got a trans-equatorial coronal hole rotating in. That could produce some significant geoeffective activity if it stays intact. And here's some of the latest imagery here, the intensity gram from Lurmouth, Australia. And you can see a little bit of darkening right up here to the northwest of sunspot 2833, an indication that it may be producing an additional umbra, although it does appear to be North Pole, so the likelihood it becomes a beta-class sunspot is still very low. And let's take a look at what's going on at Lagrangian point 5, stereo A. And here's the gallery from stereo A, just to show you that we don't see any coronal mass ejections facing the Earth. The likelihood of a coronal mass ejection is actually quite high right now, so don't be surprised to see one. We'll try to forecast it ahead of time. The animated imagery of the stereo A coronagraph 2 is still not viable here on the Integrated Space Weather Analysis Center. So I'm just going to advance the still frames here to show you the latest still imagery from it. And we don't see any ejecting on the latest imagery. Global geomagnetism currently calm. We only see a KP of 2. This brief geomagnetic storm condition was caused by that South Pole-oriented coronal hole we talked about for the last couple of days. And let's take a look at the real-time solar wind. So normally we only show a one-day chart of the real-time solar wind. Today we put up a 3-day chart, partially to show this extremely definitive signal of a coronal hole wind stream. You can see right here, the solar wind density drops off. The solar wind velocity comes up. And we also see a signal in the plasma temperature and some shifts in the BTBZ. So all of the characteristic signals of a coronal hole wind stream. Again, we do see it subsiding. And we're going to switch this to the one-day chart here, which is what we normally show. And there's 1 day of solar wind data. You can see this solar wind velocity subsiding here, having reached all the way up to about 600 kilometers per second for some brief pulses in that high-speed coronal hole wind stream. It wasn't accompanied by any strong magnetism or anything like that, which is part of the reason why it was so non-geoeffective, only having produced a short 3-hour or less geomagnetic storm condition. Current conditions are about 540 kilometers per second for the solar wind speed. Solar wind density, 6.66 protons per cubic centimeter. Next, looking at the geospace via the space weather modeling framework. It's 4 hours of data, magnetohydrodynamic pressure, and we can expect to see this subsiding over the next day or so. Again, not expecting any additional pulses from that coronal hole system. It was fairly well defined. Anyway, that's 4 hours of magnetohydrodynamic pressure in nanopascals. Next, looking at nanotesla on the ground level. Geospace delta B, ground magnetic perturbations. We see pulses coming out of the oceans once again, and perturbations associated with the Canadian and South geomagnetic pole. Also magnetic perturbations south of South America. Has the South geomagnetic pole split as well? Leave us a comment and let us know what you think. Anyway, it's 4 hours of data during this geomagnetic excursion. Cheers. If you weren't aware, we're also on BitChute, and we expect to make more exclusive content there on BitChute soon. And there are some videos that have been demonetized and so on YouTube that are now only available on BitChute. Hydroxychloroquine. We also do regularly stream to Twitch, which we'll be doing in a moment for our cosmology and meteorology segments. If you haven't checked us out over there, you want to see the videos first before anybody else, check out twitch.tv/smashamash, twitch.tv/smashamash. Thanks to our Twitch followers as well. Most of all, thanks to our YouTube subscribers. Most of our content is there. If you're watching any place besides on YouTube, check it out. Check out the playlists as well, youtube.com/smashamash/playlists. Thanks to our new subscribers, we'll be doing a 2,000 subscriber special when we reach that milestone. Having not even reached 1,900 yet, we've barely begun creating content. You ain't seen nothing yet, as we're not even full-time, folks. Next, I'd like to thank our patrons, who are full-time awesome. Thanks, patrons. Now, our patrons are the true source of funding for the content on these videos. And if you'd like all kinds of information nobody else gets to see, consider becoming a patron at patreon.com/smashamash. Thanks again, patrons. And the rest of you non-patrons should be thanking our patrons as well, as they're increasing the likelihood these videos will continue to exist and remain publicly visible and free for all to view. By the way, we'll be streaming live for the solstice. Welcome to the brightest week of the year, or if you're in the southern hemisphere, the darkest week of the year, as we approach the June solstice, and we want to be the first channel to wish you a happy solstice, so make sure you view us at 11:32 p.m. We'll be streaming live to Twitch and to YouTube, possibly even to Facebook. So make sure you check us out on all those platforms. And we're going to do a cosmology segment. It'll be streamed live to Twitch. It'll be a separate video, so make sure you check that out as well. It will not be integrated in today's daily space weather. And next, we're going to take a look at the electron content around planet Earth. Electrons have the ability to charge up satellites. And we see some minor charging hazards happening here over places like the Caribbean, Central America, and the Central Pacific. Electron flux has moved into warning levels. If you were a patron, you'd probably already know about that. And here's the one-year chart provided by Solon.info, and you can see this sudden precipitous uptick in the electron flux. It came a little later than we expected. But as that coronal hole wind stream subsides, there you go. Electron flux now into warning levels. And again, we saw some extreme anomalies in the ionosphere once again. We've covered it for about 3 days now. Here's the relativistic electron forecast model, and NOAA is forecasting even higher levels of electron flux here. I would tend to agree. Don't be surprised to see some communication errors, GPS errors, and so on as a result of that. The green boxes are the forecast. The yellow diamonds are the observation. So next, looking at the total electron content forecast, this is a visualization of the electron density for the entire air column. It gives you an idea of where your GPS errors are most likely to happen. And this is actually fairly organized here. We see more organized levels of electron flux here. We see more organized Van Allen belts, basically, when we see higher levels of electron flux, and we see more chaotic ones at lower levels. But that didn't stop the ionosphere from behaving in an anomalous fashion. Anyway, that's electron density for the air column. And here's a diagram of the Van Allen belts. Feel free to pause the video. Distances are shown in miles. And here's the ionosphere, and it's looking very anomalous. Again, we're seeing these sudden charge-ups down here, these high vibrational regions in places like the South Pacific Ocean. Those are relatively unexpected, and we've never seen it before on the channel. The sun is north of the equator since we're approaching northern hemisphere summer. And so those are some anomalous ionospheric behaviors there. And for you new viewers, what you're looking at here is vibrational frequency. We can see some high vibrational frequency just west of the South Atlantic anomaly, which is located someplace about here. What can I say? That's 1 day of data. And so some extreme ionospheric anomalies over Central South America. Here's the latest image from 9 o'clock Universal Time. And we're seeing basically low-frequency ionosphere at that moment, 9 o'clock Universal Time. And here's a diagram of the atmosphere, a different diagram, showing you distances in kilometers. The F over here on the right, that's the layer we were just looking at. One little slice at about 300 kilometers, the bridge between space and Earth, the F ionosphere layer. And we're going to do a meteorology segment, so if you're only watching the Daily Space Weather, make sure you check out our playlists, youtube.com/smashamash/playlists. And we just recorded our meteorology segment live to Twitch, twitch.tv/smashamash. Make sure you check that out if you're only watching the daily space weather videos. Let's get back to our daily space weather video. And here's the latest hydrogen alpha imagery at 6,562.8 angstroms. And I would note massive filaments up here, over here. You can see some extending over the limb over here. The likelihood of coronal mass ejection still there, folks. Don't be surprised to see some ejecta headed in the Earth vicinity. This is the latest imagery from El Teide, Spain's ground-based observatory, part of the National Sunspot Observatory. And here come the rest of our bonus features. It's the thematic map, part of the GOES 16 SUVI. Sunspot 2833 has largely remained stable. And here's the latest imagery of it. We press refresh there so you know you're seeing the latest. And so if it is growing another umbra, it is North Pole. So we're expecting this to stay as an alpha class sunspot here. Again, that little umbra there leading it is the same polarity. So it's all North Pole polarity, folks. The likelihood of major solar flare is not that high as a result of that. Here's some imagery to close things out. It's the sun in 304 angstroms ionized helium. Probably a crowd favorite. I like it. It does a great job of showing filaments. Here's 171 angstroms full disk. And we'll show you a close-up magnetogram of sunspot 2833. To close the video out first, 171 angstroms. Close-up of sunspot 2833. And there's the SDO magnetogram. So quite a close-up there. You can see not a lot of changes happening with the magnetic fields associated with sunspot 2833. Thanks for tuning into the Daily Space Weather, folks. Remember, tell your friends and foes about the channel. And may that solar wind be at your back.